Okay. Now, am I audible? Am I audible? Why you always respond in chat box? Cannot you speak? You have to respond like that. Your audio is always muted. I think that's why. In the end of if my syllabus will finish, then I will ask some vivas. Then you have to speak. Okay. And okay. Okay. So Sideslope can oh, I have started the recording. Okay, no problem. A side slope channel is that which is aligned at right angles to the contours. That is along the slopes. Okay, these things already we have discussed. Let's go to the next part. Kennedy's seal theory. I'm clicking the screenshots of your attendance. Okay, I already noted. Mm, yes, precaution during alignment. If you align a canal, then there are some precautions you should follow. The canal should be aligned on the ridge in such a way to obtain the maximum command. So these are the important things. Next is your canal linings. That was also important point. And what are the canal linings? Ardent type and another is hard surface lining. These are the two important types of canal lining. Next, another important point is advantages of canal lining. Why you have ad, what is the benefits of using canal lining? That means why you line the canal or unline canal. If you line the canal, then you will have maximum uh, production. Maximum that means what you can say irrigation command area. The water you can convey through irrigation will be maximum in case of line canal. Okay. Next is Kennedy's. Another important point is your Kennedy's seal theory. What Kennedy says, R.G. Kennedy have R.G. Kennedy given some assumptions and one theory to study the silt. That means the suspended particles behavior. To study the suspended particles, Kennedy given some assumptions and According to R.C. Kennedy, what he says, what he investigated, that canal systems for 20 years and come up with a Kennedy silt theory. This theory says that the silt, that means suppose this is your canal bed. Here is, okay, what happened? Okay. Suppose this is your canal bed. Here is some silt. Water always carries some suspended particles, isn't it? So that will also flow together with the water. So what happened to the silt? So he gave some explanation regarding this silt deposit. The theory says that silt carried by flowing water in a channel is kept in suspension. So they will held in suspension by how? By the eddy current rising to the to the surface. Okay, that means some eddy currents which is rises from the water from the bottom, and that is responsible for the silt particle suspension. The vertical component of the eddy current tries to move sediment up. This eddy current tries to move the sediment in upward direction. Okay, whereas sediment weight try to brings down, and there will be some self weight of this sediment particle, isn't it? So that will again oppose this eddy current resistance. So this weight of the sediment tries to bring it down. So if uh, adequate velocity available to create eddies so as to keep the sediment just in suspensions, silting will be prevented. Suppose if we can prevent, if we can hold particulate matters which is flowing out together with the water, if we make them to in suspension, then it will not flow along with the channel, isn't it? So silting will be prevented. Sorry. So as to keep sediment just in suspension, silting will be prevented. So in this way, silting in an canal. Silting means deposition. Somewhere means suppose in a particular side of the canal, silting is there. So the flow will be less, isn't it? The bed level will arises and flow will less. And that is why Kennedy gives some theories related to this silt deposition. Okay, so silting will be prevented. Next, yes, in this figure you can see eddy's force according to silting. Let me take it. So suppose these are the particulate materials. This is the particulate materials, and these are the eddies. Eddies means eddies are like three-dimensional flow. Okay, three-dimensional water current. So that eddies will force the particle to float in the surface, isn't it? But in the particles, it will have some self weight. It will have some self weight, isn't it? So that weight is responsible to come down to the bed, and it will resist the force of these eddies, isn't it? So, Eddy's force, according to Kennedy's seal theory, so Kennedy discovered that these eddies are responsible for uh, held the particle in suspension, and this particle self weight of particles is responsible for silting. Okay, so he made some assumptions. What are the assumptions? Number one, the eddy current is generated because how it is eddy's current. He also gave some explanation regarding this eddy's current, how it is generated. So this eddy current is generated because of the friction between the flowing water and the roughness of the canal bed. And second assumption, the quality of suspended silt is proportional to bed width. That means the quality of particle is proportional to this bed width of the bed. Last, third one, the theory is applicable to those channels which are flowing through the bed consisting of sandy silt or same grade of silt. So this theory is only applicable to those channels which is having flow and which having uh, particle matter, suspended particles like sandy silt, only applicable in case of sand material. Okay. Next, critical velocity based on Kennedy's cell theory. Critical velocity. So let's see what is critical velocity according to Kennedy. Critical velocity is the mean velocity which will just make the channel free from silting and scouring. The velocity is based on the depth of water in the channel. The general form of critical velocity is this one, V naught equal to C d to the power n, where V naught is critical velocity, D is the full supply depth. That means the depth of water, full supply depth. And C and N, these are the constant. And he find out the constant C value equal to 0.546 and small n value 0.64 respectively. How he find out that is not available, but he found to be that this constant value should be 0.56, 0.546 and 0.64 respectively. Okay, have you understood? So this equation 1 can be written as V naught equal to 0.546 d to the power 0.64, isn't it? Just put the value of C and N. So it will be this one. So mark this as equation 2. D means suppose this is your canal. Okay, I cannot draw here properly. Suppose this is your full supply level, because in mouse I cannot draw it properly. Okay, so this is your D. Okay, this one is a D, depth of water. Someone is waiting in a lobby. Let me make them in. If I go back to the screen, then again this WebEx is interrupted. That's why I cannot. Four-person is waiting. The meeting is gets locked automatically. Okay. So what is the equation of critical velocity? This is the equation. And what is critical velocity? The definition is given here. Moreover, this equation 2 further improved upon realization that silt grade influences critical velocity. Grade of silt means the size of the silt. So it will affect the critical velocity. That means if the size is more, the velocity should be more to move this particle, isn't it? So that will affect the critical velocity. So a factor termed as critical velocity ratio introduced in the equation, and this equation 2 is modified as V naught equal to V naught equal to 0.546 m d 0.64. Here one term is introduced, m. Okay, so what is m? Where m is the critical velocity ratio. So he modified the equation where he introduced m, one term m, which is called critical velocity ratio, which is equal to actual velocity divided by critical velocity. That means m is equal to v divided by v naught. Value of m provided in the table. So he had introduced the values of m as for different types of silt. So different types of material of the canal lining he introduced as for line canals. That means the types of lining and the values of it should be and the values of m. It will for art material the m is it should be m. Okay, the value table and values of m based on a type of silt. So for canal lining, if it is ours, the value is 0.0225. For masonry, it is 0.02. For concrete, it is 0.013 to 0.185. Which one is less? Which one is having less? Which one is having less value among these three?
Earth, ma'am.
Which one?
Earth lining.
Arts lining, arts canal has less or concrete canal?
Concrete, ma'am.
Yes. Which one? So concrete channels have less value. Again, uh, in Kennedy's theory, there are some drawbacks also. Okay. So what are the drawbacks? Limitations of Kennedy's cell theory. The trial and error method used for the canal design using Kennedy's cells theory. That means in Kennedy's theory, there is not a proper way of designing the canal. Okay, all the theories are, that means based on trial and error method. Okay, so there is no equation. Second one, there is no equation for bed slope assessment. So the equation developed by Cooter's equation is used to compute the bed slope. So Kennedy didn't provide any equation for that, did not provide any uh, terms in the equation for bed slope, isn't it? There will be some bed slope, so he didn't provide for bed slope. So what we have to do, we use Cooter's equation to compute the base law. So what is Cooter's equation? Where have you got this? In hydraulic engineering, design of channel, you have got this formula. Okay, Chase's formula, uh, and that one is your Cooter's formula is there. Manning's formula. So to compute the bed slope, Kennedy didn't provide any slope assessment. So the equation developed by Cooter's equation is used for the to find out the bed slope. Third one is the ratio of channel width. That is B. This is your B. B and depth. B and depth. B by D ratio has no significance here. Okay. The ratio of channel width to the depth has no significance in Kennedy's seal theory. There is not perfect definition for salt's grade. That means he didn't provide for larger course. That means course material. He didn't provide any information regarding course material or the material which is smaller than these s- smaller in size. He didn't provide that size. Didn't provide any information regarding the size of the particles. So that's why this equation is not perfect. And definition for Salt's grade and salt Charles. Okay, salt grade and salt SARS. He didn't provide information. Next is complex phenomenon of silt transportation is not fully accounted. See, those who have taken the river engineering as elective, then they will understand the regime theories. Okay. Next, we are going to do that. So, in river engineering, you have you have got to know what is critical velocity actually, how silt is carried out in a river, in a channel. Okay. So flowing phenomenon of silt transportation is not fully accounted and only critical velocity ratio and concept is considered here. That's why this equation is omitted. Next one, design procedure of canal using Kennedy's seal theory. How can you design a canal using this seal theory? There are two cases of canal design using Kennedy's seal theory dependent on a given data. Both cases represent below. For case 1, the following data shall be available beforehand. Discharge, rugosity coefficient, critical velocity ratio m, bed slope. Assume suitable full supply depth d. Then find the mean velocity by using Kennedy's equation 3. After that, find the area of cross section by using continuity equation, Q equal to AV. Then find out QAV. Here, one term is the rugosity coefficient. And what is that? That is your roughness coefficient. Okay, the channel roughness. These are the steps 1, 2, 3, 4. And number 4, assume the shape of the channel with slopes 0, half, and half vertical, 1 horizontal. Find out the value of base width of channel. Then number 6, find the perimeter of channel, which helps to find out the hydraulic mean depth R equal to AP, where R is the hydraulic mean depth. A is the canal cross-sectional area, P is the perimeter of the section, and number 7 step is your finally calculate the mean velocity using Peters equation. His equation is this one. Let me show. This V equal to 1 by n, 23 plus 0.00155 divided by s, whole divided by 1 plus 23, 0.00155 s into n into root over r, where n is the rugosity coefficient based on the type of canal lining material, and there is a table for this coefficient which provide n values, and s is the bed slope. Okay, these are the values of n for arch. Already these values are given. So next is your case 2. When ditchers n and critical velocity are given, so these are the steps. I think problem is not given here. I will show one problem. Next case 2 is this one, and another theory which is a little bit acceptable than Kennedy's theory, and that is given by Lacey's seal theory of canals. So next class we will discuss about this Lacey's theory and comparison between Lacey's theories and Kennedy's theory. Okay. Okay, I will share the notes whenever Lacey's theory is completed, and I will share together. Okay, thank you. You can leave. 35 students present today. Omid Pangang, are you okay? Don't leave. Omid Pangang, are you present? Omid, Pranay Chakraborty, absent. Omid, absent. Margak Mayak, present. Okay.
Yes, ma'am.
Okay, then you can leave.